Good morning. All right, audio seems to be good and going out. Everything is good. And once again, good morning, Katali. It is hopefully going to be another good week. I think the weekend was pretty good. We got, I think, good feedback for the Sunday show between CJ of the Coding Garden and me. And if you haven't seen that, I will try to remember to put a link to that live stream / video into the descriptions. You can go watch CJ of the Coding Garden and me talk a little bit. At the very end, we did a tiny bit of programming where we created a, We created a Chrome extension that replaces the word the with a random emoji. So, but today we're back to my normal scheduling, which is going through the nature of code. So if you haven't heard of the nature of code, it is a book where you pay whatever you want for it, and you can actually read it online for free if you would like. Oh yes, I found a use case of generators too. Well, like I had discovered that use case a while ago, and that's like, I actually learned of using generators through using iterators with Rust. That's sort of like what opened up that spot in my brain for me. It was like, oh man, I could create my own iterator, and that's what a generator is. So I just replaced the word generator with iterator, and bam, that it suddenly makes sense now. We are on to the last section of Chapter 2, Forces. I do actually own a copy of this book, but if you're following through, I'd love to know if you're doing that, and also, what do you think of the book so far? So we're going to the very end here, and we're doing everything attracts everything. They do have this or repels, but we're not going to do that. We're going to do everything attracts everything. So in the last time, we created a single sort of a planet almost that attracts a whole bunch of other satellites, as it were. Well, we have here, we're going to be creating where we just throw a bunch of satellites or planets in on the screen, and then they all just sort of attract each other. I love how they just like, when I'm not on screen, it got a little bit weird. Let's reset that. And then this is what we're going to try to create today. Miguel, good morning. You did make it. I am doing good. It was a good weekend. I don't know if you caught the interview that I did with CJ. And I guess it wasn't really a true interview. It was just sort of like co-stream. And I got a bunch of like pull requests accepted for the BBGGEZ project. I got a bunch more overnight. So I think I'm gonna maybe, like, if we get finished earlier today, we can take a look through some of those or discuss them. You know, I don't ask very often, but like, how are you all doing? Hope you all had a great weekend. Quite good? Oh, awesome. That's good to hear. I think code program. I have an actual workspace for this. So you're open there. Traction, we no longer need you, so move you. Okay, so CD, Rust, nature of code and Rust. That's where we want to go. I remember what I'm doing. It's not like I'm tired from the morning. Okay, so we are doing exercise 2.8 mutual attraction. Cargo, new. Is it example or exercise? It's example. And I can now open this folder. All right, the first thing, we're going to change this name to be slightly better. We'll just call it mutual attraction. Version and all that stuff is good. Dependencies. Well, we're going to go get our BBGGEZ library and pull that in. So it's been a little bit busy. First of all, I don't know why, but the documentation link is now there. I could swear that it was not, that it was just repository independent crates first, but it is there now. So now we can go and take a look at this documentation if we want to or need to. Also, yes, it is version 050. So we've been a little bit busy and added in a bunch of cool things into there. So I'm going to pull that in. Katali, you've also been working on the idea of the file changes. Again, just as I asked that question, Firefox Twitch freezes. Oh no, that's terrible. Okay, well let me give you the quick rundown again. So things have been going well. This weekend I had a sort of like sit down co-stream with CJ from the Coding Garden stream, and that is coding.garden. And so it's more of like web development type things. But Katali, you were there, I believe, and it was it was actually a really good size, like number of people watching. And we, I think like we were going to do one again sometime in the future. But until then, like I might even have CJ come on to this stream. Anyways, I'll have the link to like the actual stream, like when I do the VOD. But you can, if you go to like Coding at Garden, you go to visit Coding Garden on YouTube, you can go and like find, it's the most recent one, you can find it. I might as well share this. I actually opened this up so I can share things out with you all. ATD, good morning. We love CJ. It was a great time. Well, awesome. Yeah, CJ is a really awesome person. I do like him a lot. Yeah, it was mostly a chatting stream. It wasn't really a programming stream. We might be doing one of those sometime more in the future. Oh well, thank you, ATD. I hope that I'm inspiring you to like move forward in like how you want in life, and get to where you want to go. Okay, so we have BBGGEZ. We're bringing that in. This is now bringing in GGEZ for us. So if we want to get like our basic setup in main, we're gonna use BBGGEZ, and I think this might be run. So we're gonna pull in run. And what I'm gonna do is, we also need to pull in the, let's see, use, what did I call this? Mutual attraction. And I'm gonna make this the main game. And then, come on, mouse, work with me. There. Oh, also forgot connecting Twitch highlighter. I showed this to CJ, so he might actually install this this highlighter, which I think mostly works with Twitch. I don't think there is one for YouTube yet, so it'll be interesting to see like the Twitch audience for his streams can now do it. I also need GG-Easy utility. Do I need it in this one? I don't know. Let's find out. Right now it's like telling us we don't have this game, but we'll fix that soon enough. Okay, so we have our main. We now need to do our run function. It's going to take game, which is a reference, mutable reference. So we should just be able to do that. Oh, we need to create a new game. So let game equals game new, like that. Then this becomes game. And I suppose you need to be mutable. Okay, so then we have our title. So this is the title of our game. So we're going to call this mutual attraction. And then the author, me. And what does run? Run doesn't even return anything. It just will handle its errors. That's it. And I think that's all I need in this file. So like, look at how clean main.rs is now. Stings need to be referent. Well, really? I think that's fine. We'll find out if we get an error. Of course, right now it's yelling at us because we don't have a game object, so we need to create that. So in our source, we're going to create a live.rs, and we'll find out what errors we get and then fix those. So let's start with pub struct game. I think right now we can use our glib to sort of build all of this out. So here's our pub struct game. We're not even bringing in a rand anymore. We're just sort of creating a new game here. We're handling the window size change, all of the stuff that we want. And so now, theoretically, this should work. We should get something. Let's see. Oh, I want to do this. All right, we'll have to compile everything. Out of curiosity, how many of you are playing around, like actually programming in Rust? Doesn't have to be for like a day job, because I don't do it for a day job. I just do it here on stream. But how many of you are playing with Rust? And of those, how many of you are playing with the nature of code and GGEZ? There's some useful pull requests. Yeah, I saw that there's some good ones. And I think I got the random point in the boundaries in last night. Okay, so we got our errors, and this will help us like determine what we need. So use GGEZ event and event handler. Okay, so we need all of these to pull in library. Okay, so use of undeclared type or module, GGEZ, right. So the problem here is that we don't really have in the library GGEZ available. So if I take you out, we're gonna have to say use BBGGEZ, and then in here, GGEZ from that. And then of course we need like whatever this else needs. Miguel, REST, only toy, projects, self-teaching, nature of code at the moment, only tweaking your code and trying things out. Oh, awesome. I'm glad you're sort of like tweaking that code and playing around with REST. Okay, so we know that we need things like context. Let's see. Game error. Actually, I don't think we need game error. I think we need game result. Graphics. Timer. Event handler. We need the point to. Oh, point to. There. And vector 2. All right, let's try that. Still got an error, unresolved import, mutual attraction. Okay, so we couldn't find, did I misspell it? No, I did not, but maybe it's one of those RLSs being silly things. Okay, so let game, oh, okay, so new game requires something. What did we have game require? Oh, the context. We need to pass in the context. So this is interesting. We need to get that first. So let's go take a look at the BBGGEZ runtime example and see how we're supposed to be doing that. Okay, so he has game new. So he made a change to our game. To get the context in there. Or maybe, let's see, because I thought it was working with the example. I tested that. Or maybe, oh wait. Wait, that's mine. Back to you. So we're creating a new game. Oh, I guess we're not requiring the context here. I'm requiring it in mine, which I have to then stop doing that. Now, I was doing that for no reason right now. So let's just not do that anymore. All right, so we got our application. It also uses like the right sizing that we had before. So our game is working as expected. So I'm thinking after we do this challenge, if we have time, we'll go over some of those pull requests. Otherwise, I'll probably just do them throughout the week as I have time to, like I did this weekend. Okay, so the first thing, what we want to do, come back to here. We need to create a bunch of the sort of like planets and then just render them onto the screen. So that's the first thing we're going to do. So let's begin by creating a planet. So you are a pub struct planet. And we know we have all of the sort of like physics-based things that we need. So we know we need like location. So we need to bring in, so use bbgz. We know we need to have ggeasy and algebra vector 2. So we're gonna have our location. We know we need a mass. It's gonna be an F32. We know we need a velocity. We know we also need, let's see, so location, velocity, acceleration. What else do we need in this? So location, velocity, acceleration, mass, those are all the things that will allow it to sort of move around. We know we need a mesh. So let's update this. Okay, so we have you, and we know we need graphics. We need, there's a mesh. We also know we need a game result. Double comma. Okay, so we're gonna have our mesh, which is going to be a game result of mesh. Shall we also re-export an algebra and bbgz? Maybe. So I read in an issue in, was it an issue? It might have been an issue, or it might have been just a comment by Icefoxen in the Discord, like the Rust Discord, that he's thinking about moving away from an algebra and like using something else. So I'm not sure if I want to then I guess we could just like re-export an algebra, and then as soon as he switches, we'll like switch to something else. Yeah, I don't know. Like that might be a bigger conversation to have. Okay, so we have all of these, like the color will go into mesh, acceleration, velocity. Okay, so we have all of these. Let's now create a new one. Okay, so good morning, Danny Fritz. N algebra is a part of GGEZ. Well, yeah, for right now it is. I don't know if that's going to remain the same forever. I'm at the one that comes with the GGEZ, so we can do UBG. Yeah, that's true. Like that would allow us to do that. So we could just re-export N algebra from GGEZ, and then that way, yeah, it just makes it a little bit easier to do that. So I could definitely see that. Okay, so what is it? Implement planet. We have this public function new. We don't need to take in a self because we're going to return a new planet. What we do, and then we're going to return a planet. In here, I'm thinking we're going to want to create this planet somewhere randomly in the arena size. Now, the problem is that we don't have the arena size because we don't have access to the context. So that might be something to sort of keep in mind, is that we need like create planets later. because we don't have access to we don't have access to the context anymore, so we don't know where the screen is. We won't have those until the first update runs. So yeah, that'll be something interesting to think about. So we'll be creating a new planet and injecting it into the system over time. I think that's what we have to do. Otherwise, we'll have to rethink our main RS in order to get the context before we create the game struct, the game instance. Danny, I know you wrote the abstraction for the main RS file. Do you have any ideas of how I can get the context into the game so I can just generate all these planets knowing what the size of the screen is? With that, we're going to say that we want. You wrote it with a context at first, but it was pretty complicated. Yeah, I can imagine that. I'm thinking maybe we want just to, on the first tick, then we'll have the context and we can then create a bunch of these. Pass it through the new function of planet. Well, yeah, so I know that. Required a box with a lambda function and a dynamic trait. Okay, that's pretty crazy. I could see why we don't want to do that then. So we do want the arena size. Okay, so we'll do the arena width. Okay, so we're gonna have that. I think we also need the context in here too, which I don't have in here. I'm not sure what else we need because we're going to create random colors from this. Oh, we need utility. That's definitely something we need. So for you, so pull you up, and then we'll use utility. All right, trying to remember those trailing commas. Okay, so now what we want to do is create our location. So our location is going to be a random location in there. I think we have that in the utility. Utility actually needs to be passed in here, doesn't it? So we're going to have utility. Actually, we can pass in the random location. No, we can't. We're going to, wait. We can. We're going to have the location actually be coming in here instead. So location is going to be our vector2 of F32. And we'll just get the arena size on the other side in the library file, and then just we'll create the location and send it in. I may not need this utility here. Let's see. Our mesh, we could create that in here. That might be a good idea to have this create that. Because the planet should know about itself. So I don't think it cares about anything else. We'll have to do this to create the content, but okay, so location is you. Let's pass in for random. I think the planets can just come in as a random number. So maybe did we re-export rand? I don't think we did. Re-exporting rand would be really nice from this. Does GGEZ re-export rand? No. Just so I can create like a random size. You also need to create a utility and then pass that through the planet object as part of utility. Yeah, I think so. So I think utility, we want to pass utility in. I want utility to have the ability to give us a random number. So like we could do rand as part of utility. So that just holds that. Is utility actually give us, let me try this. Actually, I could just pretend to pass it in. That's what I could do. So if I say utility is and I want to say mass, if I say utility dot, yeah, so this is like random. We have RNG here. RN, okay, so, okay. Utility dot RNG dot gen range. Don't do that to me. And let's say something like 3.0 to like, I don't know, 35.0. I wonder if that will work. I wonder if we made RNG a public on there. There's a PR to re-export rand. Well, perfect. And that's probably one of the things you were suggesting would be really helpful for us to, if we did it today, before I did this. Okay, velocity and acceleration are going to come in as just empty. So velocity is a vector 2 new. And then we have our mesh. So I think we can use our utility to create a circle. And we're going to create, like, this is where we're going to put it, right? So our location, well, I'm thinking 0.0, 0.0, our radius is actually going to be this mass here. So I want to actually move the mass up. Okay, so we have you there. This mass can now be the radius. We have our color, and so we want to create a new color too. So utility dot create random bright color, and then our context. And I think that does it. And that should take care of the drawing for us too. I have an idea of why I want to like create the meshes with 0.0. Is everything like the meshes all just like start in around the top left corner. So I think that would be up here for you, yeah. And then we'll use translate, which is when we draw it, to move that around on the screen. But that will, if we get used to always creating the meshes here, then we can create some really cool, interesting shapes by changing these numbers around. Okay, so if we do that, we'll come back to the library here. And so we need to now store, we need to pull in, so mod planet. use planet, and in our struct, we're gonna have planets is a vec of planet. And I think we're just gonna create an empty vector right now. Just like that. So there's nothing in it. But on update, we want to say like every X like seconds or so. So I noticed, Danny, you made some changes to the change colors to actually go based upon seconds, I think. Instead of ticks, so it's like every second. And we could do that here. Yeah, the example does seconds. We could actually go look at that and see bright colors, for example. 1,000 ticks on your laptop was forever? Oh, wow. Okay, so that's why you changed it. So we have this timer F64. You're also bringing in duration to F64 and how much time between the change. You're then getting timer, self-timer minus duration to F64. You're passing in the delta. Where's delta from? Oh, timer delta. Pass in the context. And then you're checking to see, okay, well, if that's less than now 0, then it's time to create that, and you now set timer back to 1 again. So we could do this. And then we'll also like just create a planet whenever that happens. Let's open you up to the right. So we'll need Is there a reason we need to keep the timer around? Because your self.timer, because you're resetting this every single update. So I'm not sure that there's a necessary to like store that. So here, if we just say, let our timer, oh, it's because we're also bringing in time. So oh, because you're taking, like, this is the last time, wasn't it? So like you're resetting, this is the last time that we ran it, minus the duration to this. Okay, so I think that we have a better way of saying it than timer. Delta and duration. It didn't want to autocomplete for me. That may not be a good sign. Either that or we're killing RLS and it's very unhappy with us now. So let our timer. Okay, so timing, so it knows this, timing measurement functions. Let the timer, and that means we're going to set, like on self, this is not really the timer, this is the time, this is our countdown. So is it like total time, like time processed, time taken? Maybe like countdown? So I could do like countdown and then also the add planet every. Add planet, seconds, F32. Okay, so countdown, we're gonna set this to, okay, so we're gonna start this with wherever we want, like where we're starting. So I'm thinking we'll start this with the add planets every second. So add planets every second. We can do this every like oh, I know, okay. I got an idea. So countdown, we're gonna start this at 0.0 and add planets every second. We're gonna do every 5 seconds. And that way, this will just automatically start off with adding a planet right away. Now we can self dot countdown. And so this will go into the negative to begin with, but that's fine. Self.countdown minus, we're going to get the duration to f64, and then we need to get the delta and pass it into context. And here's where we get to say, okay, well, if our timer now. So if timer is, okay, so I think we can do that. So if self.countdown, if that is now less than or equal to 0.0, then we're going to push a planet into the vector. So so we need our location. So we need to create a new location in there. So that's going to be, our utility needs to come in too. Which means we need to store that in here as well. And okay, so now we have access to that in here. Our location. So that's going to be self.utility dot. Oh, did I not? Did that not make it in? Did I not push that change in? I thought I pushed a the update that had the random location in, or was that maybe right after I created mine? I could swear I got that in yesterday because I saw the pull request for it, but maybe that was like after I was done working on it and I just looked at the pull request. It's actually here. So no, not the examples, the library. So we have the run function. Okay, yeah. So I don't think we made it. It got made in yet. I think I just talked to the person about it. I may not have redeployed it too. Like that could be the problem. So let's go ahead and create a new location here first. So that location equals, we have the arena size. That's gonna be fine. So what is this gonna be? This is gonna be a vector to new. We have also access to RNG through this. So the X is going to be self.utility.rng .gen range between 0.0 and arena size .0 utility.rng. Okay, so that should be That should now be our location in here. And now we can push in planets new, the location. We need to pass in the context and the utility. I think it was the mute self, which actually might just work as it is. We also need to, if we take a look at this, to reset the timer. So that way we don't, right, so we need to reset the timer to the add planet seconds. Self dot countdown is now going to be equal to self dot add planet seconds. And I think that will now do it every 5 seconds to create a timer. And then, of course, in draw, we need to draw out the planet. Okay, so then we have our self.planets. We have the mesh, so now it's going to be graphics, draw, pass in our context, our drawable. Not mass, mesh. And our params, so that's going to be a point to from planet.location. Okay, I think that's it. Twitch highlighter is resetting. That's cool. Hopefully it still works. Let's, this has been a lot of code. We haven't tested it out. So let's go ahead and do that now. What's the chance that this will work? None. None at all. Okay, so what are we, oh, this is a lot of errors. Mismatch types. So, oh, direction F64, expected an F32, found F64. Oh, you were storing countdown as X64, weren't you? In here, timer is X64. So that's, I could fix that. So you two need to be F64s. That should just automatically fix you. All right, what next? Field RNG of struct BB. Oh, okay. So RNG is private, so we can't do what we want to do there. So we'll go to our cargo toml. We'll bring this in, but we are already going to bring in RNG. So that'll be nice for the future. Until then, let's go ahead and do what we were doing previously. We will store in our main library. Bring in our prelude. Wait a second. This is the wrong one. Wrong library file. We already brought that in there. We need this library file. Bring you in. Store rand here. And that will be type thread range. And in here, we don't have anything else that we're doing. So this is going to be RNG is rand create. So it's just a rand thread range. I think that's it. And that will allow us to here just call self.rng. Okay, what else we got? Expected mutable reference, found struct utility. Okay, so we need to make you mutable reference 2. Okay, so the trait bound mesh graphics drawable is not satisfied. Trait is not implemented for result. Oh, I got a result back for that. Well, I probably want to just unwrap this up above instead of here. I mean, I don't want to do that. Do I? No, I want to grab the mesh. So in the planet, yeah, okay, so this is a game result mesh. Thinking maybe we just make this a mesh itself. When we create the mesh, now we're not returning, we could return a game result when we create the planet and then unwrap it there. That could work. So I could do game result planet like that. And then over in our library, when we create the planet up here, we unwrap it. And that should give us access to the mesh now. Field mesh. Okay, so mesh and location are private. So there's a bunch of these that do need to be made public. So public, we know the mass is going to be public later. Velocity, I don't know if that needs to be made public. Acceleration and the mesh. Create circle, yeah, it just returns the mesh. Okay, so there's you. Oh, this is not, yeah, that's not what I want. It's this thing is, okay, so you are creating this, we could just unwrap you right here. Let me multi-line this. So here's creating this mesh. If we unwrap, I think that will fix that problem. Is it not unwrap? Is it the other one? Like expect? Okay, then RNG, we need to pass in RNG here. Red range. It's already unwrapped. Okay, for some reason I thought I would need to do that. I think it's a game. I'm getting a game result though, aren't I? It's just easy mesh. Okay. Never mind. Okay, so we'll just use RNG to gen range to generate that. Slowly working down these errors. This function takes 4 parameters. So planet new, we need the RNG at the very end. And I think this needs to be mutable RNG. And then we're not question marking that. All right, 2 more. Can't find crate for mutual. Okay, that's your. We're ignoring that one. Okay, so planet RS cannot borrow utility is mutable more than once at a time. Okay, so when are we doing that? Oh, because we're like random create circle, it's like borrowing it twice right there. So we probably need to create our color here. So move you up there. And then color. Does utility need to be mutable? I think it does. It will yell at me if it doesn't. Does any of the calls use mute self? I don't know if it, I don't remember if it does. Although, like, I think the RNG stuff is like forces it to be mutable. Like, there was weird things that was saying, "Oh, hey, we're out of errors." Cool. Let's try this. Here's a random planet. And another random planet. So now we have random planets showing up. So that's perfect. Let's see if they're all like the same size. So far it's really hard to tell if they're any bigger or smaller. They all look to be around exactly the same. I think these two are different. Okay, there we go. That's significantly different. That's perfect. So I can leave you up. We can just watch this like grow forever. We'll probably eventually want to have a cap on these. And then now we want to do the attraction part. So we want to say for each attract to each other. So what does that mean? We need on a planet, we need like a function attract to. So we need attract. So mutable self. Actually, I don't think we need self. We just need a reference to self because I don't think we're gonna change any. We're gonna change other things, not ourselves. We know we need another planet. And I guess like the other question is, do I want to have? You know, I might want to have just like the array of all the other planets come in here. So what if I do this? Planets is a mutable reference to a vector of, and then I'll need planet. If I do this, then I'll be able to affect all the other planets. And then I think the other thing is we need to know if it's our own planet so we don't attract ourselves. So we're going to want some kind of ID in here. ID, which is going to be, I think, a usize. And when we create this, we want an ID, usize. Okay, so that way we'll create our ID here. And then we're not using game result anymore. Get rid of you. Okay, so now we'll be able to tell if we're ourselves. We're not going to return anything here. Instead, we're going to say we want to attract. We want to loop through all the planets and then run that attract code on it. So for other planet in, I guess it'll just be planets. First things first, we won't want to do anything if it's our ID. So I'm almost thinking of just saying if not, if self.id is not equal to other planet.id. So we want to make sure, okay, this is some other planet that we're talking about. Now we need to go remember how to do the attraction. So there was an entire formula we used for this. And we saw this is a, where was the attract code? Okay, so here's the attract function. Okay, so we're gonna get location. So our own location and then the other person's location. So we want to get the directions, like the distance between the two. So this is gonna be like the distance, and it's also gonna be like the direction. It's kind of like both. So I'll just call this direction. It's also like distance. I don't know. That's going to be self.location minus other planet.location. So once we have that, we now want to get the actual distance, which is the magnitude. So that's going to be our direction dot magnitude. That should be an F32. Yeah. Then it wants us to constrain the distance. So we were thinking about a new function to this. So let's do that in the new function. So constrain distance. We want to bring in the distance, and then we'll just have the minimum maximum, and this is going to return a new F32. Distance is also an F32. Okay, so what do we have here? Our distance, we want to say if distance is less than, they're doing 5, so we'll just do the same one. So if it's less than 5, then we want to return 5.0. Otherwise, else if distance is greater than 25, otherwise we're just going to return distance exactly as it is. So now we're going to say we can mute this, or we can just shadow it. Shadowing is fine too. So we're going to say self.constrain distance and hand it the distance. Okay, so we've constrained the distance. Then we want to normalize the force, which was this this direction here, and then it sort of begins to become this this force. So I'm also okay with mute and making this be the force here. So now you are also force. Force is now going to be normalized. Then we get the strength. The strength is going to be, this is like that algorithm that we get from math, and then we're going to multiply that by the force. So we'll just create that here. We can do that up here. So let strength equals, so a gravitational constant. So we should bring that in. Because this is going to be like gravitational constant across the entire universe. Gravitational. And I think that's just an F32. So our gravitational constant, which is going to be multiplied by both of the masses together. Self.mass and other planet dot mass. And then we're going to take this entire thing and divide it by the distance squared, which the distance is right here. So that's going to be distance times distance. I bet there is like an F32 squared, isn't there? I bet there is. There has to be. Okay, so then we normalize this force. Then we got this strength, and now we're going to then say force equals force times the strength, sort of to scale it up. And then we're going to attract the other planet in this case. So what is that? That's do we have that here now? No. Okay, so attract for that. That's we just apply a force. That's all it is. We just have the force. Now on a planet we need a public function apply force. So mute self and a force, which is really just a vector 2. F32, we're not going to change anything. And what are we going to do here? We're going to say, I need to turn the brightness up so I can see your name. Ice Leo, good morning. Yes, this is Daniel Schiffman's book. This is Nature of Code. Okay, so we have apply force. We want to just add the force to the acceleration, and that's all. So we're just going to say self.acceleration equals acceleration plus the force. And that should be it for apply force. We're probably also going to want like a move and everything else. So public function move itself. I don't think we necessarily need anything else in here. So in move. Oh, move is a let's do update. Move is a restricted keyword in Rust. Okay, so we're going to update now. What does that mean? We need to now add the acceleration to the velocity. So self.velocity equals self.velocity plus self.acceleration. And then we need to update the location. Self.location plus self.velocity. So this updates the location. It will now start flying around the screen. And we now want to reset the location equals self dot, no, not location, acceleration. We want to reset this to 0 each time. So, and we're just going to multiply that by 0.0 to do that. All right, is there anything else that I need to worry about? It's a lot of stuff. Distill, good morning. What graphics framework am I using? I'm using something called GGEZ, and then we're creating a community project, which I call BB GGEZ, which is extending it and making it a little bit easier for us. Okay, so this is a lot of stuff. We now need to go and back to our main library. So you are missing the ID. So for every single one of these, we need to now add in. So when we create a new one, Here's an update. When we push in, we now store what like the latest ID is. I could like just get the length of it and then set that because it starts with 0, so then it would be ID 1 for like 0. I think. Well, it would be ID 0 for that. I think that might work. I could also just like store the latest ID in here. I'm thinking self the planets to push. The ID is just going to be self dot planets dot length. That's it. Reset to 0. Every number times 0 equals 0. So it's the same as saying acceleration equals 0, 0. Wait, isn't that what I had? No errors. So that's a good sign. I think my reset to 0 is better than just setting it equal to 0 because it still needs to be a vector too. Oh, I didn't even notice. What is multiply? Okay. Sorry, Danny. I missed your question. But Katali got it. So thank you, Katali. Okay, so we've got all that. In update, that's doing that. So now we want every planet. So for planet in mute self.planets. So for every planet, attract all the other planets. So we're going to say planet dot attract all the other planets. So self dot planets, and then the gravitational constant. So we need to add that in too. So out of not knowing what else to do, I'm just going to set this to 1.0 for right now. And you need to be mutable reference. Oh, cannot borrow planets as mutable more than once at a time. Oh no. Okay, so I have heard about Nanu. Someone else mentioned it on the stream, but I haven't looked at it. So I don't really know anything about it. I have a note to like one day take a look at it. Okay, so the problem is we're constantly borrowing this over and over and over again, which is not cool. So that's a problem. So we may, because like we're looping through all the planets, and then yeah. Oh, okay. So we're just doing this over and like we're doing a borrow and borrow and borrow and borrow, but we can't borrow something we've already lent away. Which we're borrowing it here, and then we're borrowing it again here. So that's, and we can't borrow it as mutable. Can I just borrow it as a reference? Or maybe not even that? Oh, right. So that would move out of it. I don't want to move out. I want to just get a reference of it. But we borrow it here, which and I can't really just like hand it over because that's going to move it. Expected multiple reference, found struct, standard vec. Okay, so that's Now what I could do is do the other movements here, but then it's still going to be a loop within a loop, and that's a problem because we're going to have the exact same problem over again. 2 nested for loops and do well. So the problem here is, and I'll comment this out and we'll try another loop in here. We're going to run into the same problem because it's going to be like, well, hey, we have planets here. that's not going to work. The only thing I can think about is copying, like cloning other planets. That won't work because I don't want to clone the other planets because I'm not working on the real one then. So let's do for other planet in mute self dot planets. Just doing this, it should cause an error. So cannot borrow planets as it's already borrowed as immutable. Well, okay, so then this needs to be mutable. Okay. But now it's going to say cannot borrow it more than once at a time. So that's our problem now. Now we need to figure this out. Cloning the planets on the first for loop. So let's think about that. If we clone the planets in the first for loop, and then we're going to use this. Okay, so let's try that. So dot clone. No method named clone. Is it copy? Chiroptical, good morning. Can I immediately borrow an inner loop? No, because I needed to make a change on the inner loop. Copies, is it just doesn't, no method named copy. Let's see. I need to implement it. Okay, so that's, if I clone you, I can move you out. So it's not even that anymore. But you're saying you don't implement it. Okay, so now the method clone exists, but the following trait bounds were not satisfied. Planet. Okay, so planet, we need to now implement clone. So we need to drive clone. Okay, so our planet is now cloned. So we have a cloned planet. I think actually I want to say this is a planet clone, just so we don't forget. Now we're going to say planet clone is now going to attract the other planets. So this is mute self planets and the gravitational constant. Okay, no errors. So cloning works. It's not the best for memory, so as we get more and more planets into this vector, it's going to get worse and worse. But like this is the safest way to do this, and like guarantee that none of our code can play any shenanigans. Once we do this for the planet, we now need to tell each planet to update. So we need to do another loop out here because these are off of the clones. So for planet in self.planets, and here we can say planet.update. Yeah, attract isn't pure. It is doing a mutation. That's why I need to pass in immutable, yeah. You probably like just missed that code that I wrote there. Okay, let's see if I forgot anything. So one planet is there. We add another one. They should immediately start attracting to each other. No. Okay, cool. So they don't do anything. That is less than optimal. What did I miss? So we're going to go through each of the planets. they're going to attract one another. And so here's our attract. We loop through the other planets. We calculate the forces, the other planets. Wait, I didn't apply the force. So I have to then say other planet dot apply force and hand it the force. Like, that's a significant problem. Okay, let's see if that works. My alarm for end of time is coming up. So let's see if this works. I think it's working. It's a little bit strong, gravity wise. So let's make some minor changes here. For you, our gravitational constant, because I'm not using delta time anymore, let's do 0.01 and see if we can slow everything down a little bit, because that's a little bit hectic and crazy. Okay, so we create one planet there. And we've got gravitational force. We're going to add another planet, and now they all sort of start moving around together. And with each new planet added in, it's just going to change everything around. And because everything has different masses, they're all going to sort of like move at a different rate and different speed. So this is really cool. I really like this one. So what do you all think? I think that the big thing that we learned, or that we like have to keep in mind, is that that copy. So the copy on the outer loop allows us to have access to the planets for that inner loop. Otherwise, we just run into other trouble. I should add a sun that they're all sort of. I don't know how to like do that, because they're all just like fall into the sun. It would be cool to maybe like add in hidden gravitational things that they're all sort of attracted to in the middle. But for right now, they sort of look like a crazy uh like a crazy atom or something. I write is inherently 2D, right? I think you mean GGEZ is inherently 2D. Yes, GGEZ is inherently 2D. I think there's some people have managed to do 3D stuff with it, but I have not looked into that. What if the gravitational force is dependent on the mass? So I mean, it's supposed to be a constant. Like, that's not how normal physics work. But I suppose we can like have that in our universe. Things change. That we could definitely do that. Accidental eye, yeah. Um, should be gravity times mass times one. Yes, I actually have that. It is. We hold on. Let me move you over to the right. In our planet, our formula for this is right here. So our strength, gravitational constant times the mass of the cloned planet with the other planet divided by the distance squared. So it is mass dependent. Yes, it's mass dependent on each other. But I think this is good. So I'm going to start winding down this stream. I think we're also going to find somebody to raid if anybody is live. And then I think Cody Garden, I saw you send me a little message. Are you going live this morning? Okay, so what do we have in here? This is Just use stuff. We have everything tracks everything. You won't be live this morning. You woke up late. Okay, well that's too bad. I would raid you if you were gonna be live. Let me show you where all this code is. I do have it public on my repo. If we head on up to Nature of Code in Rust, it is all in Chapter 2. Example 2.8, mutual attraction. I will copy this and add it to chat here. So feel free to play around with that. I do accept issues and pull requests. I don't know if I'm going to come back and do that, but if you want to like implement whatever like sort of challenge thing you do, you can tweet at me or like do a pull request out to sort of like show off what we have. I also have a project that we've been working on together as a community called BBGGEZ. It's actually an extension for the GGEZ game engine that we've been using. And I've been actively looking at pull requests and issues for that. Part of that is for, what is it, the Hacktoberfest. So if you want to get some pull requests in for that to get a t-shirt, then this could be one of the ways to do it. And I'm perfectly happy to sort of help out with that, and you can learn some Rust. With that, I'm surprised this hasn't slowed down very much, even though I've been just adding infinite planets to it. With that, I want to take a look at what who else is streaming right now. Katali, now that you've mentioned Hacktoberfest, you made it UL. Did you get the t-shirt? I'll make this full size while I'm looking for other streamers. I don't know anybody who's online. I mean, I'm only approximating gravity. Well, yeah, that's true. I am only approximating gravity. That, yeah. I'm not gonna do like true real gravity. All right, so let's see. Anybody in science and technology that I trust? The problem that I've had in the past is we've rated people a long time ago, and that did not go very well. Some of you might remember that when I looked for some people and like they just turned out not to have our values, or they just weren't going to be good to you guys. So I don't want to rate anybody right now because I don't know anybody. So with that, I am just gonna go get ready for the rest of my day. I do have work to do. You always get people that are completely silent. Yeah, exactly. So I'm slowly moving forward, like checking other coders, and if they're online and I follow them, then I'm going to raid them because like I've seen them and I trust them. So. All right. Well, with that, thank you everybody for coming. I hope that you have a great rest of your day. I do this stream every Monday, Wednesday, and Friday at 6:45 a.m. Mountain Time. That's GMT -6, I believe. And I do for like an hour and a half or so. I then go off and do my day job. So I hope that you all have a great rest of your day, regardless if it's the end of the day or the beginning. And with that, I will switch over to the end. And I'll see you next time. Bye.